All right, let's pull back the curtain on one of the most important, yet pretty much invisible, technologies that makes the entire internet tick. Seriously, it's the unsung hero that makes everything feel fast. It's not just a tech trick, it's a core business strategy for any company that wants to keep you, well, happy. We are talking about caching. Let's get into it. Oh yeah, we have all been here, right? Staring at that little spinning wheel of doom, just waiting for a page, a video, or an app to load. I mean, this tiny icon, it represents this universal frustration. But why? Why does it happen? In an age of absolutely incredible technology, why are we still waiting? Well, the answer usually comes down to where our data lives and the journey it has to take to get to us. So here's the heart of the problem. For every single thing you do, you click a link, you load your feed, the application often has to travel all the way back to a central database to get the information it needs. Think of it like a library with only one very, very busy librarian. Every single request has to get in line, and that line can get really, really long. Okay, so this chart really breaks down the core trade-off perfectly. On one side, you've got the database. That's the source of truth, right? It's massive, it holds everything, but it's kind of slow and far away, relatively speaking. And on the other side, you've got the cache. It's tiny, it's selective, and it sits right next to the application, which makes it unbelievably fast. So this is the fundamental choice you're always making, size versus speed. So if the database is the slow, scenic route to get your data, then caching is the high-speed shortcut. It is just an elegant, simple solution designed to solve this exact problem of digital waiting. And it's what turns that frustration into a totally seamless experience. At its heart, a cache is just a small, temporary memory bank. It basically holds on to the stuff that it thinks you're going to ask for again really soon. Imagine a busy coffee shop. Instead of making every single latte from scratch when someone orders, the barista keeps a few of the most popular drinks ready to go right on the counter. That's caching, in a nutshell. It anticipates the request and serves it up instantly. But how does an application actually use a cache? It's not just one simple trick, There's a whole playbook of different strategies that engineers use to make their systems faster. So let's take a look at the most common plays. So this is probably the most common pattern you'll see. It's called cache aside. Let's just walk through it. First, the app asks the cache, hey, do you have the data for user 123? If the answer is no, and that's what we call a cache miss, the application itself then has to go to the slow database, grab the data, and then, and this is the crucial part, it puts a copy of that data into the cache before it sends it back to you. Why? So that the next time anyone asks for it, bam, it's right there, ready and waiting. Okay, so reading data is one thing, but what happens when that data changes? Well, there are two main ways to handle this. Think of write-through like paying with a debit card. The money leaves your account, and the store's record gets updated at the exact same time. It's super safe, totally consistent, but it takes an extra second. Now, write back is more like writing a check. You hand it over, you walk out, and the job feels done instantly. The money leaves your account later. It's way faster for you, but there's a teeny tiny risk that the check could get lost before it's cashed. See? It's that classic trade-off between safety and speed. So these strategies sound great in theory, but what do they actually look like in the real world? Let's scale this whole idea up. I mean, way up. Let's take a look at how a global giant like Netflix uses caching to serve millions and millions of people all at once. Just take a second and let this number sink in. At peak times, Netflix's caching system is handling 30 million requests every single second. And that's not even the video streaming. That's all the other data like your viewing history, what movies to recommend, your search results. It is an absolutely mind-boggling scale. And if you zoom out to a full day, that number becomes almost unbelievable. Nearly 2 trillion requests. I mean, without an incredibly sophisticated caching system, the Netflix we all know and use just could not function. The main databases would just melt down in an instant. So how on earth do they pull it off? Well, they use what's called a distributed cache. That means the cache isn't just on one computer, it's spread across thousands of servers all over the world. And here's the key business decision. Their goal isn't perfect up to the millisecond consistency, it's eventual consistency. What that means is they're okay if a rating you make in one country takes a few moments to show up in another. That little trade-off is what lets them serve any user from any location, making the system incredibly resilient and super fast. So by now, caching probably sounds like a silver bullet, right? The solution to all our speed problems. But, like with all powerful tools in tech, there are some really deep complexities. In fact, caching introduces some of the most famously difficult problems in all of computer science. This is a legendary quote among software engineers. And while naming things is its own special kind of nightmare, we're here to talk about the first part, cache invalidation. This is the puzzle at the very heart of making a cache work reliably. So what even is cache invalidation? Well, put simply, it's the process of cleaning out the old stuff. If the price of a product changes in the main database, you absolutely cannot show users the old, stale price from the cache. The hard part is, how do you make sure every single copy of that old data, everywhere in the world, gets updated or deleted correctly and at the exact right time? It's tough. Okay, so let's look at a classic problem that comes from this whole situation, and it has a fantastic name, the thundering herd problem. Just imagine a really popular piece of data, let's say the homepage of a huge news site, is stored in the cache. Then its time in the cache expires. What do you think happens next? Well, here's what happens. Thousands of user requests all suddenly miss the cache at the exact same moment, and they stampede toward the database to get the fresh data. This thundering herd can easily crash the whole system. The solution, though, is surprisingly elegant. You use a lock. Only one request gets the key to go to the database. All the others are told to just wait a split second. That first request goes, repopulates the cache, and then everyone else can get the new data from there, avoiding the stampede completely. Pretty clever, right? And here's another tough one. A cache has limited space. When it gets full, something's gotta go. But what's the smartest thing to kick out? Do you get rid of the oldest data, the least recently used, just assuming it's probably stale? Or do you kick out the least popular item, the least frequently used, even if it was just added a second ago? There's no single right answer. It all depends on predicting what users are going to want next. It's a game of strategic guesswork. So as we start to wrap this up, it becomes really clear that caching isn't some simple fix you just turn on. No, it's a constant, delicate balancing act that engineers are performing behind the scenes just to keep our digital world moving along smoothly. And this leads us to a crucial final question. After everything we've seen, with all of its power and all of its complexity, is caching always the right tool for the job? The answer is a hard no, and this is really important to understand. For something like a real-time stock trading app, you need the absolute latest data, period. Caching is a terrible idea. Or if your database is already super tiny and fast, adding a cache just makes things more complicated for no reason. And if your data is changing every second, well, your cache is just going to be stale all the time. It really comes down to choosing the right tool for the right problem. So in the end, caching is the art of the compromise. It's this constant trade-off between pure speed and perfect accuracy. It's the invisible engine that creates the feeling of an instantaneous internet. So the next time an app or a website loads in the blink of an eye, you'll know it's not magic, it's just a really, really smart shortcut.